Hi everyone, I want to talk to you about your separation of mixtures lab. This is kind of a new one for Chemistry 101. Normally it's a Chemistry 100 lab, okay, but they did add kind of an extension to go for 3 mixtures. So what I want to do is simply go through the 2 mixture case first. That's actually part of your lab. And then what you do on pivot is the 3 component mixtures, okay? So you've got the easy one and the harder one. Let's talk about them both. But before we do that, let's give you the old checklist, all right? First one, go to the group site, download your lab. Okay, so if you go over to the Chem 101 lab group site, GRP 101, you'll find a lab specific to your birthday. Okay, so make sure you download that one. So each of the unknowns are different, grade with a key, and you choose your experiment and your unknown based on your birthday. So make sure you download the appropriate one from the group site. Then, okay, after you've obviously watched this video, you can do these things. Go over to pivot. The 3 component mixture I think is on pivot. Just like with the density lab, you have to go over there and kind of do a virtual experiment, okay? So some of you have not been to pivot yet, okay? That didn't affect your grade too much in the first one, the density, okay, but it will significantly affect your grade if you can't do the pivot work for here, okay? So check back to the announcements. First week of class announcements, I talk about how to log on to pivot, and I talk about it in that first pre-lab for density also, okay? So you have that 6-digit code in pivot, okay? So make sure you go there, make sure you're on pivot to do this, okay? So that's your checklist, all right? Now let's talk about the math of separation of a mixture, okay? So let's do 2 component mixtures first. Let's say we got the sand, salt. Now if you did that pre-lab where I had my bucket of salt water and sand right from the beach, this is easy, okay? Hopefully you were able to figure that out intuitively, all right? But if you weren't, don't worry about it. I'm going to talk about it in detail now. Okay, so when we express answers for what a mixture is made of, we do it in percent composition by weight. So say I had 10 grams of a mixture, 5 grams of that 10 was sand and 5 grams of that mixture was salt. It's a 50-50 mixture, okay? So we do some little math later to show you how you turn grams of a component compared to grams of the mixture into a percent weight, okay? But before we do that, let's think about the experiment, okay? So if we did the experiment, and should this be class, you'd be given literally a test tube with a sand-salt mixture in it, and of course an unknown label, right? What you always have to do is find the mass of the mixture, okay? So what we do, let me move this up. We weigh a beaker, okay? All right, then off the balance, so we don't spill on the balance, we put all our mixture in there, right? And we get the mass of the mixture plus beaker. Oh, it's looking a lot like the density experiment, right? If you subtract those, what do you get? Mass of mixture. So the first port of call for any mixture analysis is finding the mass or weight of the mixture. Now I had a question pop up about, well, do significant figures apply? Absolutely. Significant figures always apply to measured quantities, okay? You just happen to be limited by your lowest number of sig figs when you do math, okay? So weigh the mass of the mixture, determine the mass of the mixture by weighing by difference, okay? So in each of the experiments, the 2 component or the 3 component, you take your stuff, you weigh it, okay? Now if you think about it, sand and salt differ on the physical property of solubility, all right? So what you would do in this experiment is you would add a bunch of water, yeah, and then stir it around, and what's going to happen is the salt will dissolve and the sand will be left behind, all right? So there's the sand, I'll just do a formula, SiO2, and the NaCl is dissolved, oh, move it up. The NaCl is of course dissolved in the water. Okay, now we're separating based on the physical property of solubility. If we just filter this now, let's turn over the page, right? We just take that mixture and we set up a filter apparatus, okay? And let's assume we've weighed this second beaker, okay? There's our filter apparatus. We pour it in there. The sodium chloride solution ends up in the bottom and the sand ends up in the top. So we've now physically separated the two components, okay? All we've got to do now, because they're separate, is just take them off individually, dry them and weigh them, okay? If we were clever, we weigh this beaker, right? So we call this beaker 2, right? So if I take this beaker 2, put it on a hot plate, yeah, all the water will eventually evaporate and leave just the salt in the bottom, dry salt, right? We can then take the mass, I'll move it up so you can see it, mass of beaker and salt, subtract mass beaker, and we get the mass of the salt, right? So that's how you'd separate off a soluble component, yeah? So you'd filter the liquid phase out, okay? You would then take that liquid with the component dissolved. Now, why does this work? Because salt has a super high melting point, right? Super high boiling point. So if we look at the difference, water will boil at a lower temperature, 100 degrees C. Get it up to 100 degrees C, the water evaporates. You're just left with dry salt. Weigh it, you know the mass of the beaker, subtract from mass of the salt. Okay, nice and easy. Over here, we got our sand sitting on a filter paper. Weigh the filter paper, of course, okay, and then take it like a little tray, put it in the oven. It will dry. So it's the mass of sand and paper minus, so you weigh the sand and the paper, okay, minus the mass of the paper which you got before, equals the mass of the sand, okay. All right, so fair enough. So that's your experiment, nice and easy. But what about the math? Okay, now we'll meet this back in class later, but I like to think about Dr. Phil. You've seen Dr. Phil, right? Okay, Dr. Phil was a man with a relatively large head. There he is. He also has a relatively large body. Okay, let's say Dr. Phil steps on the scale and he weighs 250 pounds. That's like the mass of the mixture, right? So the whole thing is the mixture, right? The sand and the salt. Dr. Phil's entire body is like the mixture, right? His head would be part of the mixture, okay? Now, let's say somehow Dr. Phil was involved in an accident, right? And we were able to measure his head by itself. 25 pounds, right? So Dr. Phil's head weighs 25 pounds. Dr. Phil's body, including his head, weighs 250. What fraction of his body weight is his head? Well, it's 10%, right? Hopefully you can see that. Yeah, so it's a tenth times 100 for a percent. So in terms of math, percent mass of component, which is Dr. Phil's head, is right. The mass of the component, or we'll just say mass of the part, over the mass of the whole times 100 for a percent, right? So the mass of Dr. Phil's head is 25 pounds. His body with the head weighs 250 times 100 for a percent equals 10%. Okay, so that's how you work it out, right? So if I do a simple formula, there it is, percent mass, let's just say sand for your mixture, right? Equals the mass of the sand, you know, what you got when you dried it, right? That's usually in grams, of the mass of the mixture in grams times 100 for a percent. You know, and you can be generic. Instead of sand, you could have salt, so you'd weigh the mass of the salt compared to the mass of the mixture times the 100. In our 3-component mixture, all right, so we have 3 things, yeah, not 2, so you'd work it out 3 times. In our binary mixture, we call it 2 things, you work it out twice. Okay, so that in essence is how you work out percent composition by mass as a percent, right? Okay, now, when we look at our separation of a mixture lab itself, there are a few little details. Okay, all right, let's read the first page. It talks about the techniques. We just brushed on those just now. Okay, but when we do the 3-component mixture, I talked about the 2 just now with the sand and the salt, right? Say I had a mixture of 3 things, which is naphthalene, sand and salt, right? Okay. Now naphthalene is an organic material, a bit like alcohol is an organic material, all right? So under a higher temperature, it will evaporate, yeah? Okay. Now this naphthalene turns from a solid to a gas directly at atmospheric pressure. That's called sublimation. So if we know the mass of the mixture, and then we just heat the thing up, and the naphthalene just disappears, right? Okay. We weigh it again. That difference in mass before and after heating is due to the mass of the naphthalene. So it's mass of naphthalene over mass of mixture times 100 for a percent. Okay, so hopefully you see how that works, all right? Now we're following like a flow chart, right? So the sequence of operations is important, all right? So you heat it up, weigh it again, work out the difference in weight. That's the mass of naphthalene. Mass of naphthalene over mass of mixture times 100 is the percent of naphthalene, all right? And then it just turns into the sand-salt mixture experiment, okay? So your remaining residue, do exactly what we talked about. You add water, swish it around. You get the mass of the sand and the mass of the salt. Individual mass of components over mass of mixture, all right? Times 100%. Now a little trick, if you think about it, all the percents when combined, all the individual percents must add up to 100, right? Okay, so if I had a nice easy mixture which is 5 grams of one, 5 grams of the other, it's 50-50. 50 plus 50 is 100, right? But maybe it's 40, 30, 30, all right? But they should always add up to 100. Okay, now don't expect perfection in this world of online education, right? We expect perfection, but no, you may get some real experimental data. So when you add your numbers up and you get 99.5, don't worry about it. You always lose a little bit in the experiment. Remember we talked about experiment, well, we'll actually talk about experimental error later. When you transfer from one container to another, you always lose a little bit. Okay, so you're never going to be perfect, all right? Okay, so I'm going to grade you with a little bit of a fudge factor. If you're within like, 1 or 2%, you get 100% for your grade. Okay, all right, stop there. Now, before I finish, I want to talk a little bit about how I grade the labs. Okay, so each lab is graded out of 100. Okay, say there's 16 labs, so that's maximum score is 1600, right? But does anybody get 1600? No. All right, so maybe maybe someone gets 1300, right? What I do at the end of the day is I grade against the best score, not the theoretical maximum. So the person that got 1300 as the highest score, everybody's graded as a fraction out of 1300, okay? What does this mean? It means that your labs are helpful. As long as you keep handing them in, okay, you'll always get a really good final grade for labs, okay? So most people get, and I assign between 100, maximum score of 150 for labs. Most people get between 150 and 120 at the end of the day. Just keep handing them in and you'll be fine, okay? Now, unfortunately, I can't return your labs because that'll mean printing 71 labs, grading them by hand, and then sending you copies back, okay? So I can't do that. All right, so this is what I don't like. There's not much feedback, but if you want feedback, come to office hours, okay? Come to office hours. I can talk to you directly about your lab at office hours, all right? But if you want to know your score, just let me know. Don't ask me every week, right? Maybe after week 5 or 6, you want to know how you're doing. I'll just send you a copy of your grades in labs so far, okay? But again, labs always help as long as you hand them in, okay? All right, hopefully that makes sense. If you've got any questions about that, again, come to office hours or, ask in the discussion area, okay? Because when we can all see the answer, right? Remember, don't email me directly with a group question, right? Ask it in some discussion area on the Canvas. All right, okay, hopefully that makes sense. We'll stop there and see you guys on the next one.